In this video, we'll generate the dataset of cosine. So array formula, cosine of the x values from 0 to 6. And we generate a Taylor series expansion of cosine centered at theta. And the value of theta is from 0 to 5. So data validation, list of items, that's 0 to 5. So at 0, it is the Maclaurin series expansion. At theta equals 1, it will be Taylor series expansion centered at 1. 2, Taylor series expansion centered at 2. We continue with the value of n, which is from 0 to infinity. So starting from 0 up to infinity. 14 is good enough. Now we complete the Taylor series expansion coefficient. So array formula, cosine. The first term is 0.5 by n. So 0.5 times pi times n plus the second term is theta. Then enter. That's the numerator. Now we can divide the denominator. The denominator will be factorial of n. Then enter. So we can expand this a little bit. We'll just change this to scientific. We don't have the space. So we could just change it to scientific. Now we can complete the Taylor series expansion. So array formula, series sum of the x values, that's x minus theta. So minus theta raised to the power n, where n starts from 0, incremented by 1. And the coefficient will be the a values, this range. Then enter. And we'll chart this. Insert chart. And we use scatter chart. And show the trend line, polynomial, to the 6th degree. For the label, use the equation. For the legend, position at the bottom. We don't need a title because we already have the equation as the label. So here's our trend line and polynomials of cosine, the Taylor series expansion of cosine. We'll calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix, starting with the power. Transpose 0 to 6. And the elements of the matrix. So this is equal to array formula. Array formula of the x values raised to the power 0 to 6. Now we can use LINEST. LINEST data y and data x. LINEST data y and data x. Start is centering at 0. So centered at 0, which is the Maclaurin series. So at theta equals 0, meaning the Taylor series expansion is centered at 0. The coefficient match x to the 0, 1. Coefficient of x minus 0.0555, negative 0.0428. Coefficient of x squared, negative 0.0354, negative 0.384. Coefficient of x cubed, minus 0.147, minus 0.123. Coefficient of x to the fourth, 0.117, 0.107. Coefficient of x to the fifth, minus 0.0201, minus 0.0184. coefficient of x to the 6, 1.07 times 10 to the minus 3, 9.54 times 10 to the minus 4. The Taylor series expansion centered at theta equals 1. The polynomial regression coefficient approximates the function cosine, and the data sets are the same, and the polynomial trend lines are the same. Centered at theta equals 2, centered at 2. So the Taylor series expansion approximates cosine. Their data sets are almost the same, and the polynomial trend lines are the same. Centered at 3, they are the same, they are exactly the same. Their data sets, this expansion approximates cosine, and the trend lines are the same. The theta centered at theta equals 4. This time, the expansion approximates the cosine theta. Likewise, the dataset approximates the cosine theta. At theta centered at theta equals 4, and the trend lines are the same. Centered at theta equals 5. Again, the trend lines, polynomial coefficients approximates the cosine, and their data sets are almost the same, and the trend lines are the same. This completes the use of SERIESSUM LINEST Polynomial Regression to generate the dataset of the Taylor series expansion centered at data from values 0 up to 5.